Here we're going to be talking about the triangle inequality theorem. So, simply said, I'm going to talk about the definition, but really it's the two short sides added together that has to be bigger than the longest side. So, it's the sum of the lengths of any two sides of a triangle, and they are greater than the length of the third side. That's what all of these inequalities are showing. A plus B has to be bigger than C, A plus C has to be bigger than B, and B plus C has to be bigger than A. Any combination we use has to be bigger than the third side. That is just simply to form a triangle. Really simple way to think about this. You don't have to draw this part, but let's say I have one side length that's 16, and I want to figure out the smallest side lengths that can create that. Let's say I have a second side that I know is 10. If this side is 5, they would not be able to reach each other. If this length is 16, even if I lay them flat down, if I bring that down and bring that down, it's not going to reach that 16. These two short sides have to be bigger than 16 in order to reach that. If they're exactly 16, then they would go along that line and it would not form a triangle. They have to be lifted a little bit, so they have to be greater than 16 when we add them together. So, we're looking to decide if these three side lengths could form not a right triangle, just any triangle. If we add the two short sides together, and it's bigger than the third side, it can form a triangle. So any combination we use here, 5 plus 6, 6 plus 6, or the other 5 plus 6, either way, that always works out. 11 is bigger than 6, 12 is bigger than 5. No matter what combination we use, the two sides that we add up will be bigger than the third side. 3 plus 7 equals 10. That does not work. That's going to form a straight line, not a triangle. 3.5 plus 4.5 is greater than 5.5. So these sides can form a triangle. 2 plus 5 is less than 8. They would not be able to reach a length of 8, so those do not form a triangle. All right, on the next one, two sides of a triangle have the following measures, so they're giving us two of the sides. Find the range of possible measures for the third side, and we're going to write our answer as a compound inequality. Compound inequality is like this, but there's really two inequalities put together. I'm just going to draw an example. X is bigger than Y, and Y is bigger than Z. That is a compound inequality. So we're trying to say the smallest number that it could be, the third side, and the biggest number it could be. So we have to imagine these are the two bigger sides. What would the smallest number be to get us up to 38? X plus 25 has to be greater than 38. If these are the two short sides, this imaginary made up third side and this 25, what would that have to be bigger than 38? That would have to be 13. 13 plus 25 is exactly 38. We also have to imagine the opposite, where these are the two short sides. 25 and 38 are the two short sides, and they have to be bigger than some third side. Just adding those together, that would have to be 63. Those are the possible ranges. Can't be exactly those numbers, because then it would just form a straight line on both those. But it has to be a little bit bigger than 38, a little bit smaller than 63, so X has to be in between those two numbers. We add them up to find the biggest it could possibly be, and we subtract them to find the smallest it could possibly be. Same logic here, that should be a comma. We're going to subtract these two and find out that 12 is the shortest the short side could be to reach. With this as the second shortest, 12 and 28 put together would get us up to 40. So X has to be bigger than 12. But it can't be bigger than 68 because 40 plus 28, the furthest that could reach is 68. It's got to be a little bit smaller than that 68. That logic is the same each time. You add them and subtract them, add them and subtract them to figure out the biggest it could possibly be and the smallest it could possibly be. Add them and subtract them. Oops, I was getting to the answer already. So it couldn't possibly be bigger than 4. It's got to be bigger than 0. So any length bigger than 0 will reach from 2 to 2. And 2 plus 2 couldn't possibly be 4 or bigger. Same logic here. Subtracting 5 is the smallest it could be. Adding 105 is the biggest it could be. Actually, I'm not saying that right. It's got to be bigger than 5. It can't really be 5 or 105. It's got to be smaller than that. All right, last one. In triangle DOG, point C lies on the line of the triangle between points D and O. DG is 5, GO is 12, and just DC is 3. What are the possible lengths for DO? So we want to figure out what does CO have to be, and then think about what is DO, what are the possible ranges for DO. First off, it's important that you see that this does not have to be the longest side. Even though it's drawn that way, it seems like it is the longest side. It's not going to be drawn to scale, so we don't know that this is the longest or the middle side. And you might be able to do this without setting up inequalities. You might be able to kind of just guess and check at that side length. I'm going to set up the inequalities anyway, just to show you. So I'm going to label this as x. So this side would be x plus 3. So that's one side length. That side plus another side plus 5 has to be greater than the third side. I'm going to set this up with each combination. So x plus 3 again plus 12 has to be greater than 5. And then 5 plus 12 has to be greater than x plus 3. So you can notice something about that middle one that's already wrong. That really can't happen. Where this is a shorter side than that. That just already can't really be true. Also, if you were to solve that, you'd get 15 there, you'd subtract it over and get that x is greater than negative 10. That is not possible. We can't be talking about negative side lengths. You can't have negative 5 as a side length there. So really, this inequality is not going to be used. We're really just going to use those two, thinking that this could be one of the two short sides or it could be the longest side. Solving both of those, this would give us 8. We'd subtract it over to the other side and you get 4. So x is bigger than 4. On this one, we'd combine like terms there. You'd get 17. And it's greater than x plus 3. We'd subtract the 3 over to the other side. So x is less than 14. So x is somewhere in between 4 and 14, which means that that side length, adding 3 to that, is somewhere in between 7 and 17. This you can easily double check. Adding those together gives us 17. Subtracting them gives us that 7.